Okay, video number 2. Hopefully keep this one short too. I see if I can. Um, First of all, I wanted to say about the discussion board question this week. I actually changed it uh, just a couple of days ago, what the question actually is. And um, I we've the four of us, I think, have no trouble finding ways to criticize modern science and a worldview that's completely based on that. I see a lot of sophistication in everything that you post about it, so I didn't feel a need to go further into that, and instead decided to try and go the other way into appreciation. So, um, what? How do we? The question is more on the side of how do we appreciate modern science, and I don't mean just from and in the trivial way, which is that, oh, it's given us all these comforts and modern medicine and things like that. I mean, in what other ways might we appreciate modern science? Even does it, like I think it's a very interesting question as to whether modern science actually contributes to our spirituality at all. Is there any contribution? I gave you the reading this week, which Ken Wilber says that there's no possible contribution from science to the spiritual side of lives, the religious, the spiritual, the mystical. That there's absolutely no intersection, no way that it relates at all. It's separate, it's an entirely separate function, and that's his view. And I'm wondering if that's our experience, and what is the interaction between science and our spirituality, and is there a positive side to that? Is to me an interesting question. And so from all of what we've been through is, and even perhaps from what you might call a mythological perspective, or does modern science actually make something clear to us that makes our spirituality make more sense, almost like in opposition to this modern scientific worldview, we find some other part of ourselves. So it was just an exploratory question of that nature, just to see if there's anything there that's of interest to work with. Anyway, in this video, I wanted to talk about a little bit about my experience with story in science. And to do that, I feel like I need to talk about, so what is often, we often think about when we think about science is people in lab coats, in laboratories with equipment doing experiments on things, and experimental physics is of course like that. One can do a lot of engineering in laboratories, but I'm going to say a little more about this. I don't think of engineering as actually being science. So engineering simply uses known principles to make things that we use. So it's not really science in the sense of the exploratory research science that we typically talk about. And the thing about laboratories and engineering are that what they do is they're designed to limit the variables. So what they do is they make the world very much more simple inside the laboratory. In the region of the experimental apparatus, I used to work in a magnetic field free room. There was no magnetic field in there. We'd taken out that variable. And so in the laboratory, we limit variables. We make the world very simple so that we can then do these experiments and where we know that there are few variables, perhaps even only one or two variables, get it really down low, and then we can twist the knobs, change the variables, and see how the experiment comes out differently, and then we learn, basic things about how things work. But that is, that's a part of science, and I think that's it's certainly not the whole of science. It's a limited part of science. But much science happens outside the laboratory. So sciences like geology, ecology, oceanography, atmospheric sciences, planetary sciences, all kinds of other things happen outside the laboratory. They happen in the real world, what we call the real world. They're where you can't limit variables. So, and what I have observed is that it's a very different kind of science that happens in that world. And that was my world. So I'm working on studying the my research. I was studying the Earth from space, and trying to measure global change, and those kinds of things. And it's really, really complicated. I mean, the Earth is really complicated. Even this yard out in front of me is incredibly complicated. The number of variables at play are enormous. So there's this thing that happens where the number of variables that might affect something you're studying, you need, in order to understand that system, then you need at least an equal or greater number of measurements that are independent from one another. It's what's called orthogonal. So you have to have a lot of independent variables, measurements, to determine that number of variables. Well, you almost always, more than 90% of the time, you don't have that. You don't have enough independent measurements to cover all of the variables that might be at play. And so what that means is that when you do an experiment and collect data, the explanation of that data, how you might explain that data, is non-unique. Okay, and it's explicitly so. Okay, from a theoretical point of view, it's non-unique. So, and that means that there are multiple answers, presumably out there in space, which you may, and many of them you may not know, that can explain that data. And that is the situation for most of science outside the laboratory. And that's true in the realm of medicine as well, in a big way, because the human body is so complex and there's so many variables. So in a formal way, we're dealing with non-unique explanations of data. Okay, so there are so in the space of explanatory space, there are many possible answers, and now you may prefer one answer, and you usually do. So, and then so you argue for that, and you say, well, you know, for this reason and that reason, I'm going down this road with this explanation. Let's start calling it story. So for this reason or that reason, I'm going with this story. Okay, but now there are many possible stories that could have fit that. They are all obeying the rules. They all follow procedure that's required. They all take account of the necessary laws of nature, and they all explain the data. So for this reason, the world of story becomes much more significant. This is just my experience. My world, I felt like I was not making up stories, but I was actually choosing stories that told something that I wanted to tell. They conveyed something that I wanted to tell. Now, I could give the same data to other scientists, and I'm sure that they would tell different stories. And that is really a reality of science, as I say, outside the laboratory. Now, within the laboratory, because you've limited conditions so much, then you've limited this possible story. Still, it applies because there may be variables you don't know about and other complexity. So story becomes really a part of your life. Everybody's telling, in science that I knew, everyone was telling stories and being rigorous in terms of procedure and data and having explanations that fit what we know currently. But nevertheless, we're all telling stories, and so for me, once I left science, I started to look at it I started to think, well, how does a particular scientist choose a particular story? And it's got a lot to do with who that scientist is. It's in some ways, the kinds of story that you tell are more telling about the scientist than they are about the thing being studied. So I'm just throwing that out there. We'll follow up perhaps more on that later. But different scientists choose different kinds of stories. Now, if you get into a subject that we say are all somewhat familiar with, say the research and ideas about biological evolution, you get into that in detail. You don't have to go too far before you start to see that there's a lot of different stories coming from evolutionary biologists. They're certainly not all agreeing with each other. Now, they do close ranks when it comes to creationism and intelligent design and everything. They're like, no, it happens like this. It's like, but then in the closed doors, in the conferences, you see a lot of variability in ideas. And I'm like, wow, these are you could give each of these scientists different kinds of data, or the same data, and they're going to come up with a different kind of story, each one. And I think that's very interesting to me. And back when I was at Naropa, I wrote a large essay on that because I decided to use developmental theory, Ken Wilber's developmental theory, to see if I could study what kinds of stories particular scientists would pick on this subject of evolutionary biology. And I thought that I could see an evolutionary ladder of the kinds of explanations that scientists would pick. More scientists who had more developmental, had more development behind them, were further along in Ken Wilber's development, would choose different kinds of ideas. And so I guess I'm throwing this out because I want to at least convey the possibility that science does not end up being independent from the beings that we are, right? It's created by beings. And so you can particularly see it in a thing like this, where the data allows you to choose different kinds of explanations. Then what you do, what you see in a given set of data has to do with who you are as well as your training. And so the personality, the psyche, you might say, of the scientist is playing a role here, a significant role. And I don't think there's any way to escape that. That's what I thought I could see anyway. And it was an interesting way to turn things around. So story, at least in science outside of the laboratory, not so obviously within, in fundamental physics, but I still believe it's there. I really do. I think that the degrees of freedom in the data are larger than we might know. So, but certainly in science outside of the laboratory, then there's this freedom, this non-uniqueness, this ability to formally choose different kinds of explanations, and some explanations become in vogue, in fashion, right? And everyone jumps on that bandwagon, and then another kind of explanation, and it all goes like that. I got quite disillusioned with that whole sort of mode of science, that it seemed like there were times when things were fashionable. It was fashionable to think this way, and then that fashion would change with time. And I didn't want to be fashionable. I wanted it to be true. But at that time, I didn't even know what that might mean, really. So, okay, so that's science and story. And I want to, there's a final, talking about story, I want to go into the whole issue of our creation story and randomness, because I think that's a very significant part of, a very telling part of the modern scientific creation story. But that would be another video, because this video has already gone on too long. So I'm going to stop this one and then make another one. I know it might be in the next few days, but I hope all of this is going okay. And you please comment and post about any reactions to these, negative or positive. And again, having a great deal of fun with what you're coming up with, everything. It's really, really wonderful. Okay, bye.